Okay, if you are in Miss David's class, you should be on page 15 of your notebook. If you are in Miss Patrick's class, you should be on the next blank page. You should have the chart glued in, and it should be titled Multiple Representations Chart. If at any point in the video you get behind or you need to hear something again, you can always pause and rewind. We're going to start here with ordered pairs, and ordered pairs should be familiar to you. Ordered pairs are listed as two numbers with a comma inside parentheses. These ordered pairs have these special little brackets around them. They're just telling you that they are grouped together. They're representing one thing. So ordered pairs are just individual data points. Okay. Then we move on to the table. The table is your XY table, your input-output. If you look at the first column in the X's, each time they are increasing by 1. So you can see the relationship between the X's. If you go to the Y's, you can see each time they're increasing by 3. And there's actually a special name for this on your Y's. It's called the first difference. And the first difference, if it is the same, tells you this is linear. If the same. And a linear equation is just an equation that is a straight line. So because this is 3, 3, 3, 3 each time, the first difference is the same, so it is a linear equation. You can also see a relationship from X to Y. Negative 2 times 3 is 6. Negative 6. Negative 1 times 3 is negative 3. 0 times 3 is 0. 1 times 3 is 3. And 2 times 3 is 6. So the data, you can see relationships between X, Y, and X and Y. So the data in the table shows us relationships between X, Y, as well as X and Y. The next one we have here is just an equation. You have seen equations before. This shows a relationship between X and Y, just written in a different form. Now the next one you may not be familiar with. This is what we call a mapping. If you look at your table, the data here is the same as the X's, the data here is the same as the Y. So this shows a relationship between X and Y to determine if it is a function. And we're going to discuss more of that next week, but the mapping shows you that negative 2 is related to negative 6, just like in the data at the top. Negative 1 is a negative 3, so all this is the same. Then the last one, if you will draw arrows on the end, somehow they got left out. This shows you the type of function. Shows the type of function. And like we talked about up here with the first difference, this is linear. You can see this graph is a perfectly straight line. This is a linear graph. We have different types. We have quadratics and other kinds, but this one is a straight line, so it's linear. So we have one more thing we need to write, and you can just write it along the side or on the bottom, wherever it will fit. All the representations show the same relationship but in different forms. All the different relationships we have here, all 5 of these, show the same exact relationship. They're just shown in different forms, but they all mean the same exact thing. Okay, so you are done with your notebook for the weekend. You can replay if you need to.